Die Sprachübertragung beginnt jetzt. Alle Teilnehmer befinden sich im Zuhörermodus.
So, hello to everyone. I welcome all participants. My name is Gero Kreuzfeld from CFturbo and I'm the organizer of the webinar today. So currently there are more people coming in and therefore we will wait a few more minutes. Thank you for your understanding. So I think we should start the webinar now. Yeah, again, many thanks for your participation in this webinar. My name is Gero Kreuzfeld from CFturbo and I'm the organizer of the webinar today. I will start with a short introduction to the content of the webinar and then hand over to my colleague Oliver Felde, who will give you a detailed information and a live demo of CFturbo. This webinar will be recorded and the video of the recording will be available on our website later in the video area. If you have any comments or questions during the webinar, you can ask them in the questions area in writing, and we will answer some of the questions at the end of this webinar and all the others by email if there is not enough time to answer all questions. So altogether the webinar will take about 40 minutes. Let's focus on CFturbo now. Starting this year, we switched to 2 CFturbo releases per year, one in spring, this is release 1, and the other one in autumn, the release 2. And the version is now linked to the year, and therefore the current version is 2020 release 1. In this webinar, we would like to present you the most important new features of this release. And we will not give you a general introduction to the software CFturbo. For this purpose, I recommend the video area on our website. So, Oliver, are you ready to start?
Yes, I'm ready, Gero. Thank you for the introduction. I'm going to share my screen now. Okay, you should be able to see my presentation now. As Gero already...
Oliver, it's an empty screen.
Oh, wait.
So we do not see the presentation. Yes, okay.
Okay, all right. Okay, as Gary already told you, I'm going to go into the most important new features, enhancement, and so on. And I'm going to start with our simulation, integrated simulation solution, and with the according interface. And this is based on Cimerix. And we already had a very strong interface. We had Cimerix very deeply integrated, and we were and still are able to very quickly export all necessary data like geometry and boundary conditions and stuff like that to Cimerix out of CFturbo. And you see here an example of a mixed flow pump that was designed in a couple of minutes and was exported afterwards, meshed with a very fine mesh. And on an i7 processor notebook, the converged solution for a steady state simulation could be reached after 26 minutes, which means you can very quickly design something in CFturbo and you get a very comprehensive and robust answer of the behavior of that design in a very short time. So what we did in the latest version was we added a feature that allows you to set up mesh refinement zone. And that is very important if one really wants to get results for the simulation of a secondary flow path flow, which of course occurs between shroud and casing. And very often you have very thin gaps there. And if you don't have the right mesh quality there, then you don't get the correct leakage flow. And that's why in the export panel, we added this refinement area where you can set up which zone in the meridional region you want to where you want to have a finer mesh. And I want to show that in CFturbo there is our standard example, an NQ20 pump that is shipped with our software. And here you see the 3D model of it. And if we go to the meridional view, you can easily see that there is kind of ceiling here with a very small gap. And that's an area that I want to remesh with a finer mesh as with the standard values. On the export panel, there is a list of interfaces. So we have the basic interface, we have the cut interfaces so that you can easily export everything to any third-party cut package in order to make some further design there. And we have the simulation part where we have a lot of interfaces here. And I'm going to talk about Cimerix. The only thing that you have to do is select all the components you want to consider in the simulation, tell him where is the directory you want to run the simulation, and then maybe do some settings here. Because I want to show you the refinement feature, I add a new zone here, tell him what is the box size in which I want to have this refinement zone. So it should be from -2 to Z equals 16, and from 47 to something like 57. And of course, I can set up everything else, but by default, we export a control file that holds the boundary conditions that come from our global setup, and it holds all settings for a steady state simulation, and that's why I don't have to do anything more. I can fire up Simeric out of CFturbo, and that's what I want to do here in order to show you that how deep Simeric is integrated into CFturbo. And once the export is done, Simeric is fired up and the meshing runs immediately, because all the necessary information, including the refinement zone, is already included in the control file. The exported STL data that describe the geometry is exported and loaded, and Simeric can immediately start with everything, and it will split the geometry in a set of nodes just according to the control file. And after doing so, and after some checks, everything is prepared, and one could start the simulation just simply by pushing the button. But of course, you also can change boundary conditions and stuff like that, just if you want to have a simulation with a different operating point. So now everything is loaded, everything is meshed, the boundary conditions are set, and I could start the simulation. And of course, that is so quick in this presentation because I had just one single stage pump, and it would be much more, or the mesh would be much bigger if there was, for instance, a big 3-stage machine. But at least that's going to show you how CFturbo is working together with the Simeric simulation. Okay, as I said before, no user interaction is really needed because everything is exported. There are even some user-defined expressions already defined that can give you answers concerning head efficiency, stuff like that, but everything can easily be customized, and all that shows you that Simeric really is very deeply integrated, and it can be very efficiently used in the design process. Okay, next feature I want to talk about is the Ansys Workbench extension that we also ship with CFturbo. This solution has been there in the old version of CFturbo 2, but now we have again done a couple of enhancements. The Ansys Workbench extension allows for the bidirectional parameter update. It enables automated turbomachinery design exploration and optimization. It will be installed if you install CFturbo, but if you don't have done so, you can also go to our website, download the Workbench extension, and can integrate it in your workflow. So what we did is we did a lot on structure synchronization, and which is most important, now name selection is applied entirely in the complete workflow. Again, I want to show you quickly how you would use it when you set up a CFturbo based workflow in the Workbench. Once the Workbench extension is installed, it should be there in the extension manager, and you should find it on the left hand side. Just grab CFturbo, drag it into the scenery, double click on setup, and CFturbo will be started. Here it is. And again, I choose one of our standard example, which is the NQ49 pump. And when I started CFturbo out of the workbench, there is that menu item here called Ansys Workbench. And with the help of that, I can tell two things. One is the definition of a set of parameters I probably want to change in the workbench, for instance, in the framework of a DOE or an optimization cycle. And that's why I'm choosing some parameters like numbers of blades and maybe the blade angles at leading and trailing edge. That's one thing. And the other thing, one, of course, has to define export interfaces for certain components that should be used in the workbench. So for instance, for the bladed geometry, I'm going to use the TurboGrid interface, and for the volute, I'm going to use SpaceClaim. And once this is set up, I can close CFturbo, have to save the project, and now I have two items here underneath the setup in my CFturbo container. Okay, just quickly, I'm not going through all the steps to set up the workflow, but quickly I want to show you how to make the most important one. The impeller and the inlet stator should be meshed with the help of TurboGrid. This is added here, whereas the volute should be meshed with the Ansys Mesher. And once this is done, of course, that has to be guided through the simulation node, which is CFX in this case. And the same, of course, applies to the volute. Now I could go into each of these applications, TurboGrid, Mesher, and stuff like that, could set up there all the necessary parameters, but this is a bit beyond the time we have here in that webinar, and that's why I'm not going through all of that. Maybe I show you the parameter set, because that's what I have selected before. So we have the number of blades here, which is 7, and what could be changed here. And there are a couple of blade angles, because that model is done on 5 spans. So we have 5 leading edge and 5 trailing edge spans that can be adjusted here. Okay. These are two major enhancements towards our export interfaces. There is one new design mode that is called blade loading, and this is to be found in the mainline design step, just right underneath the design mode. And so far, we had 3 different design modes, which is the MT representation of the geometry, the blade angle M representation, where one can directly change blade angle distribution, and the peripheral projection, which is used for special blade shapes like radial element shape. And now there is a fourth design mode, and the idea is that if the relative flow angle distribution is defined properly, one can derive from it also the blade angle distribution. And to this end, one needs information about the velocity triangles at any position, plus about the incidence and the deviation. And for the deviation, of course, there are a couple of models available and also implemented in CFturbo. And to close the whole description, one also needs the attachment and the detachment points, and especially the detachment point is well known as the Stanitz radius, and if one puts all together, one has a complete set to define the blade angles just from a given flow angle distribution. The flow angle distribution, again, as I said, is coming from the velocity triangles, and one needs to do some expressions, if you like, for the meridional, for the circumferential velocity component distribution. And in CFturbo, it is done on the basis of the derivative of the swirl, because if one integrates that distribution from leading edge to trailing edge, it can be, or it is related to the Euler work, which means the area underneath those curves is is related to the Euler work times divided by the speed. So what we did was we implemented a parametric description of that derivative of the swirl distribution, and by integrating it, we can incorporate some boundary conditions to that. The parametric description is based on 3 polynomials in 3 different positions, and there are 5 parameters that describe these distributions, and these are the delta at the leading edge and on the left-hand side, then the 2 meridional positions that connect the 3 polynomials, and then there is the shroud, the slope in the middle, and those 5 parameters together with the stacking position, that's the 5th parameter, describe entirely that blade loading. Okay, and in CFturbo, it's, as I said before, just an extension of what we already had in the meanline design step. And again, I want to show you how it would be used in reality. Again, I use that CPNQ49 example. Open the meanline design step, and under blade loading, you find under design mode, you find this blade loading design step, and all the spans are represented again with a certain derivative of swirl distribution. We have a control point to control that delta at the leading edge. The slope will be controlled by that seesaw in the middle, and the connecting point of the 3 polynomials will be controlled by that seesaw outer points. And everything is again embedded into our normal design process. So you get immediately an updated 3D preview. You get immediately an update of all the information that are available. So for instance, the relative velocity distribution on any span will be updated once I have released the control point. And again, this new design mode follows our strategy that you get immediately a feedback on any parameter change, because of course you want to see immediately what you get if you do so. Another thing, what we also wanted to make sure was that if you for some reason want to switch between the design modes, then we want to keep the 3D geometry as good as possible. So for instance, if I switch to the MT conformal mapping design mode, of course there was a little change of 3D geometry, but it's very close to what we had before. and now you can make use of this different parameter set. Yeah, it's just up to you and up to what is your preferences. And of course, I could do the same also with the blade angle distribution mode, and then it's easy to just adjust the blade in a normal way. Okay. Together with that new design mode, we also implemented a feature to define a stacking position in the MT in the conformal mapping mode. This is not necessary because the mean line is already defined with a leading edge position and a rep angle. But in the blade loading and in the beta M mode, each span is designed almost independently from other spans, and that's why it's necessary to tell where is the stacking position of every span. So for instance, here are given 3 different stacking positions. First one is stacked at the leading edge, and I think it's easy to understand how this will be done. If I go back to CFturbo, you see here the stacking position is 0 at the leading edge and 100 at the trailing edge, and the stacking angle again is the one that will position the blade at a certain tangential position in the impeller. Okay, another new feature is the definition of the rake angle specification. So the rake angle is the lead angle at the trailing edge, and it's defined like given here. And in CFturbo again, there is a new group where you can tell if you want to set a certain rake angle and where you want to set it. So I could do it here at the trailing edge and could tell him that the rake angle should be 20, and then again immediately the 3D will be updated and you see what you have done with that change of the rake angle. The rake angle can be applied for certain blade shapes, and those are freeform 3D blade shapes and the ruled surface 3D blade shape, which very often is used for the compressor design. And of course, one restriction is that the meridional edges are straight edges. Okay, another new feature is that for the fast initial design of multi-stage machines, if I go to CFturbo, close that example and make a little design of a 3-stage compressor, for instance, then you will see where this new feature might help. It is meant for those that want to quickly make a multi-stage design for the most important dimensions. And my design point is as given here. I leave everything apart from these 3 design points to default. So I also could change, of course, the gas I want to consider and the model. Once everything is defined, this window, which is certainly known to you, appears, but now a new menu item is given here, which is called the Stage Designer. And if I choose that, that window will appear, and I can tell how many stages I want to design, and then I have to tell him what is the energy distribution between the 3 different stages. And once that is done, 3, in this case, impellers with our standard settings will be designed without any further actions. And within, within half a minute, we have an initial design of the compressors. And now we could go ahead, could add templates of certain stators that we also have newly implemented in order to fill that gaps between the impellers and made the design ready. And then it could look like our standard 2-stage impeller that we ship with the software just after a couple of more design steps, and that's why I'm show that here. Okay, with saying that, I come to my last slide. Of course, this was only a set of the new features. There are a lot of more smaller features and a lot of stuff done underneath in order to make CFturbo more robust, more user-friendly, and increase the performance. And that's why I would like to tell you that if you are interested in more details, please see our website and find out more in our video area. Okay, I'm at my end, and I want to give back the moderatorship to Gero.
Yeah, thank you, Oliver, for the presentation. Now we have time for some questions. Yeah, you can ask some questions now. And currently we have 2 questions in the questions area that we should answer. The first one is related to the new blade loading design mode. And the question is, can the new blade loading design mode be used for optimization? And if yes, are there any advantages compared to the other design modes?
Okay. Of course, it can be used in optimization because we follow the concept of making everything parametric, and also all the parameters of the blade loading design mode are parametric. I said that per mean line or per span, there are 5 parameters to describe the geometry at any span. It's just the same number as if you would represent the span in the MT mode. So from an optimization perspective, it doesn't have an advantage against other modes, but of course this is up to the user, and everybody is welcome to use that in the optimization cycle.
Okay, thank you. The second question is related to the stage designer that we have seen in one of the last slides. Can the stage designer be used for impellers only, or also for automated stator design?
Right now, it's just usable for the impeller design, but this is just kind of a starting point for further development, and we will do a lot more on that initial stage designer. So our final goal is that you will be able to in the future to make an initial design of the whole multi-stage machine, and I think that's on a good way, because we already have implemented a couple of stator templates that will be used in the future for that stage designer feature.
Okay, so currently there are no more questions. Yeah, the time is up now nearly. Thank you again for your time and for your attention. And of course, feel free to contact us later on if you have any additional questions. And I hope you were satisfied with the webinar, and maybe you will attend some other webinars next time again. So, and of course, if you are not already an active CFturbo user, and if you are interested in testing CFturbo, you can simply register on our website in the download area and get a free license for 1 month to play around with CFturbo. And this is an unlimited license, so you can really test the productive working with CFturbo. Okay, thank you again. Oliver, anything more to say from your side?
I just want to thank everybody for taking your time, and also I want to encourage you to contact us, in case of any questions, recommendations, and so on. Thank you and bye-bye.
Yeah, thank you. Bye-bye.